Welcome to this third tutorial in the tutorial series on third medium contact in COMSOL. In fact, in this tutorial, I don't want to show you contact, rather I want to show you generally how regularization can help you stabilize a solution if you have very large deformations. So what we're looking at here is a column that one of my colleagues has designed using topology optimization. And the column is made of a hyperelastic material. And we're dealing with geometrical and material nonlinearities at the same time. And what this structure can do is that it induces local buckling here at the center at some certain fraction of the global buckling load. So this column will be loaded. And when it hits a certain fraction, you will see the center buckling, just like you see this part of the structure buckle. So that way you can know when the global structure will buckle, or at least you have an indication of when it will happen. So now let me just show you how the structure buckles right from the beginning. So here you see the entire column being loaded, local buckling. And now you have the global buckling. And what my colleague has done here is that he has actually pushed the column beyond these buckling limits and continued pushing until some of these features, they are overlapping. And in order to solve this, we need some regularization. And in this modified model that I got from a colleague, he's using the HuHu-LuLu Regularization. But in the paper where this structure is published, it's in PNAS and it's linked in the description. He uses the HuHu regularization, and the regularization is very important in order to retain stability when you have parts of the structure that are so highly deformed as these parts. As you can see here, they're actually overlapping, and that's because there's no contact implemented in this model. And you can see there's also overlaps here and there and over there. So the results are not really accurate when you go to this point, but it is still able to converge, and that is due to the regularization applied in this case. So if you're ever dealing with structures like this, where you have very large deformations, then try to consider implementing some of the regularization. It will stabilize your model by a lot, most likely. And then the way that my colleague has implemented it, that is very much like the first video in the tutorial where I showed you how to implement the HuHu regularization. Now the implementation here is just the HuHu-LuLu regularization. So it defines the Laplacian term for the HuHu-LuLu regularization, and then he subtracts the Laplacian term from the HuHu term. So it's HuHu minus LuLu, and that's what's in this test function here. So you see the entire HuHu, and then it's minus the Laplacian term, which is the LuLu in the end. And these already have the correct scalings for the dimensions in front of them. Yeah. So if you want to implement this yourself, then you can simply, instead of writing this yourself, just copy it directly from the description. You can find it both for 2D and for 3D. And then just follow the instructions in the first tutorial in this series. That's it for this tutorial.